Hi everyone, welcome back to my channel. Today I'm excited to bring you the latest video. I hope you like my last video. So have you ever thought about how important transcription is in our day-to-day life? Whether you're watching videos on YouTube or joining virtual meetings on platforms like Google Meet or using voice assistant like Siri or Alexa, transcription plays a big role in turning spoken words into text. Let me give you an example. Imagine you are in a Google Meet and you realize you need to take notes. That's where transcription comes in handy. It helps us capture and record what's being said in meetings, making sure we don't miss any important details and helping us work more effectively. Today, we are going to talk about transcription and how we can use advanced technologies like OpenAI Whisper model to turn audio into text with great accuracy and speed. Let's explore this amazing tool and let's get started. We will be using Google Colab for this tutorial because it provides free GPU access which speed up our inference time significantly compared to using just the CPU. So now let's head over to the OpenAI Whisper documentation to get a better understanding of what we are looking with. So the Whisper model is basically a transformer based model. You can see the transformer architecture here. We're not going into deep into this. So here is the encoder part and this one is the decoder part, which follows a self-attention mechanism, allowing it to efficiently transcribe audio. Alright, let's dive into the code. So we'll open our Google Colab. We will create a new notebook. And we will change the runtime type to GPU, and then we will just install the dependencies, change runtime type to T4 GPU, so here you can see it is connected. Now I'll just install the dependencies first. So I'll install by using pip install OpenAI Whisper and I'll run this. So it is downloading OpenAI Whisper. So here you can see the Whisper is successfully installed. Now you can run Whisper -h to just see the parameters you can pass for the transcription. So here are all the parameters you can just pass in the Whisper. First of all, I'll just upload my audio file here. I'll go to downloads and this is my audio file. I'll just upload it. So as you can see, the audio has been uploaded successfully. Now I can just use Whisper and then audio path, copy path and paste it, and I can define model as medium and language as English. So I'll run this. So it is just downloading the Whisper model, which is of 1.42 GB because it is medium model. And you can check the parameters here as well. So see, I have defined the language as English. I can set the device as well, but default it is CUDA as I am using the GPU. It has successfully transcribed the text in 1 minute 23 seconds. So this text is just from my previous video. Hi everyone, my name is Gaurav and this is my YouTube channel. So you can see it has given the quite good result. and it took 1 minute 23 seconds. So what if we want to use the large model? So we can use the large model as well. We'll just copy it and I'll paste it here, and I'll just mention it as large, and I'll run this. So first of all, it will download the large model. As you can see, the previous model was of 1.42 GB and this is of 2.88 GB. Now I'll check the inference time. For first one, it took around 1 minute and 32 seconds, and now we'll see for large model. So it took around 3 minutes and 43 seconds, which is not a good number. So now let's move on to a different implementation of Whisper model, which uses C translate 2. So I'll show you the faster Whisper. I'll show you the GitHub repo. Basically, it is using C translate 2, which is a fast inference engine for transformer models. And then I'll just write the code, and you can see here are the models like Distill Large V2, medium models as well. So for installation, we have to just install the dependencies. So I'll write the code from here. I'll just install it by pip install faster Whisper. As soon as it gets downloaded, I'll import the WhisperModel class from faster Whisper. So I'll import WhisperModel. I have successfully imported the WhisperModel. So now I'll define the model size, like which model size I want to use. I'll use large V3 model. Now we will create an instance of WhisperModel class with the specified parameters. Name model is equals to WhisperModel, and the parameters I'll pass is model size and device. Device I want to use is CUDA, as I'm using GPU, T4 GPU. And the compute type also I want to define. Compute type is equals to float 16-bit floating numbers, and I'll just run this. Now what I will do is I'll just define a function and I'll just name it as transcribe file, which will take a file path as an input. So I'll just name it as transcribe file, and which will take file path as an input. So it contains, the transcription contains the segments, and the information is the metadata associated with the transcribe file. So here is the model dot transcribe. Here we have file path and language. File path. Now it is correct. Now we will initialize an empty string named transcription text. Is the empty string, So we'll define a for loop for segment and segments to append the text of each segment followed by a new line character to transcription text. We'll just do a transcription text is equals to segment dot text plus followed by new line character, and what we will do is we will just return the transcription text. Now I'll mention the file path. File path is, I'll just copy the path and mention in file path. I'll just name it as result is equals to transcribe file and file path, and I'll just at last print the result. So it is using C translate 2. I'll just run it and we'll just note down the inference time. So you can see in 33 seconds it has given me all the transcription happened, and it is quite good. So in 33 seconds it has given me the whole transcription, so it is quite good if I'll compare it from the OpenAI Whisper. So it is quite fast, so I can use it in the future purpose. So if you want to use this code in your local, you can do that as well. So I'll just show you how to use it in local. First I'll create a folder, name Whisper, and I'll open it in VS Code. I'll write command prompt and then I'll write code dot. It will open my VS Code, and I'll create a Python file name a.py. So first thing first, I'll just create a conda environment. For that I'll open a command prompt and I'll write conda create -n whisper python equals to 3.10. So it will just create a conda environment. I'll initiate that environment to install the dependency, that is faster whisper. So proceed yes. So I'll write conda.dat activate whisper. The whisper is being activated successfully, and I'll install the faster whisper. Pip install faster whisper. It is being downloaded. The file path I have mentioned here, I have to move it in my folder. The file is present inside downloads. Here it is. I'll just copy it and paste it in my folder. Now I'll open VS Code and I'll just copy the relative path and mention it in file path. I'll save the code. Now I'll run my Python file, python a.py. So it is downloading the model. tokenizer.json, model.ben, vocabulary. The model is successfully downloaded, but it has given me some error, runtime error, CUDA failed. So yeah, obviously I have to define it as CPU because right now I'm using it my local. I have no GPU access here. So I'll just save it and I'll run the code again. But it has given me some other error as well. It has requested float 16 compute type, but the target device of backend do not support. So yeah, from float 16 I'll just mention it as default and I'll just save it and I'll run. In local as well, it has successfully given me the transcription text and it is quite good. So we can use this model in local as well. So lastly, if you are interested in deploying this model as a Flask API on Google Cloud platform, stay tuned. I'll be covering that in future video. Thanks for watching.